Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from the chapter wave optics. Okay, and this question is based upon the superposition of the waves, especially the transverse wave. Same concept will be used in the 12th also for the light wave. Okay, because light is also one kind of transverse electromagnetic wave. Okay, so let's go through the question and let's learn all this basics. So the question is, two waves of intensity ratio 1:9 cross each other at a point. Okay, that means they are going to superimpose at that point. Now see, the resultant intensities at the point when first part waves are incoherent is I1. Okay, so when they are incoherent, what is given? The resultant intensity is I1. Second part, waves are coherent is I2 and differs in phase by 60 degree. If I1 by I2 equal to 10 by x, then x equal to how much here? Okay, so as you can see very well, for the resultant intensities they are using the term I1 and I2. Okay, so for the individual waves we cannot use I1 and I2. So what we are going to use? We are going to use wave A and wave B. Okay, so let's see here. So according to the question, I can write here intensity of wave A by intensity of the wave B, ratio how much is given here? 1/9, is it? After that, when we'll simplify this, what we can write here? See, we can write here, remember that here, this IB we can write here 9IA, is it? Remember this here. So intensity of the wave B is 9 times of intensity of the A. Okay, second one, remember that here resultant intensity formula is given by, the formula is what? Can you see here? IR equal to the formula is I1 plus I2 plus 2 root I1 I2 cos phi here. Now, and in this formula, remember that here there used to be the two waves. Now, how many waves used to be there? Two waves. One wave intensity I1, second wave intensity I2. But in our question, what is this? I1 I2 is used for the resultant intensity, is it? So what we can use here, instead of I1, what we are using? This, instead of I1 we are using IA, instead of I2 we are using IB, and here at the place of IR, depending upon the situation, we will use for first situation I1 and for second situation we will use I2. I hope so things are very clear. Okay, so now students, what we can do here, remember that here for the first condition. First condition, remember that here they have given the waves are incoherent. Incoherent wave, remember that here the phase difference between the waves is used to be 90 degree here. Okay, or we can tell the cos value will be 0, because cos 90 how much here? 0, is it? So if I write here, for the first situation I1 is given by first wave IA, second wave IB plus 2 root IA into IB, and there which kind of wave? Incoherent wave. That means we'll use here cos 90. You see, in this situation, anyhow, you will see YDSC. That means in Young's double slit experiment, what will happen? The interference will not be possible here. Okay, but anyhow, they are telling here the situation. So what we can write here? See, this I1 is given by here. IA means as it is, plus IB. IB how much here? 9IA here. Is it? So 9IA. And cos 90 anyhow how much here? 0. So this term will become anyhow 0. Is it? So we can write here, what we can write here? See, this I1 will become here IA plus 9. IA how much here? 10IA. Is it here? Is it? So what is coming here? The first thing we have got here, I1 how much here? The I1 is coming here 10IA, depending upon the condition A. Okay. Now students, after that, if we talk about here the next condition here, this condition B. Here what they are telling that here the resultant intensity is I2 and the phase differs by how much here? 60 degree here. Okay. So depending upon the question, if I will use here, see, as I2 is equal to, we can write here first wave intensity IA plus IB plus 2 root IA into IB into cos 60 degree. No? They have given in a question. That means here IA, IB how much here? We know very well here 9IA plus 2 square root of IA into IB value 9IA and cos 60 how much here? 1/2, is it? Now what will happen that here, students? This 2 and this 2 will anyhow will cancel out, is it? That means we can write here, hence I2 is equal to IA plus IA, or IA plus 9IA how much here? 10IA plus square root of 9IA square. That means it will become here how much here? 3IA here, is it? So 3IA here. So overall we can write here this I2 is coming here the 13 IA. How much coming? I2 is coming here 13 IA. Now you can see very well, I1 is coming how much here? 10 IA, is it? And I2 is coming how much here? 13 IA, is it? So if in case, if I'll take here the ratio, now depending upon the question, they are telling the I1 by I2. So I1 by I2 will come here, see, I1 means 10 IA, and I2 how much here? 13 IA here, is it? So what this will become here? IA is cancelled, that means we can write here 10 by 13, is it? And in the question, what they told us? They told that I1 by I2 is equal to 10 by x, is it? So when you will compare here x, and here how much here? 13 here. Is it, students? So what you can think, the value of x how much here? Yes, guess please, the value of x will be how much here? If you will see from here, the value of x will be how much here? 13 here. Is it? Can you see it very well now? So students, I hope so this question based upon the superposition of the waves, especially the transverse wave, is very clear to you. Keep studying, keep growing.